All right, let's go ahead and take a look at capacitor discharge. Welcome back to another topic. The topic we're going to discuss now belongs to topic number 5, electric fields, and then the topic about capacitors after electrical fields. This is about specifically capacitor discharge. So we're assuming that you know about capacitors, the fact that the main purpose of them is to store electrical charges, and then release them at a given rate. Now, we know we can calculate the capacitance of any capacitor simply by dividing the amount of charge stored on that capacitor by the voltage, and this gives us its capacitance. The unit of capacitance is measured in farads. Now, consider the circuit I've drawn. We have a circuit. There's usually a switch on these types of circuits. There is a resistor with about 900 ohms of resistance, and the capacitor has a capacitance of 0.03 farads. Now, what happens generally is a capacitor is usually connected with a resistor, and the capacitor is only then allowed to start to discharge, because if the resistor is not there, then the discharge of the capacitor is going to be done at a really fast rate, and that's not really going to be useful. You want the capacitor to release the charges, the voltage, and the current in a more slowed down and more cool manner, so that it can actually be useful. Now, we know capacitors have a lot of different uses. For example, car courtesy lights or camera flashlights are some of the most, basic uses of capacitors. But capacitor discharge is a very interesting topic, because once you learn about capacitors and then go into this topic, you really learn how they actually release the charges they store in themselves. Now, before we go ahead, I would suggest that you subscribe and continue this journey on learning, and I wish you the best of luck for whatever exam you're getting ready for. So without any further ado, let's go ahead and take a look at this question now. So just consider the circuit I've given. Usually in such circuits, we are supposed to find something called the time constant, known as tau. Now, tau is the time taken for the current, voltage, and charge to drop to 37% of their original value. You can calculate the time constant, or tau, simply by multiplying R times C. So tau here, which is the time constant, can be found simply by multiplying 0.03 farads by the amount of capacitance. Actually, I wrote that the other way around. Capacitance is 0.03, while the resistance is 900. So 900 ohms gets multiplied by the capacitance, and that would give us a time constant of 0.03 times 900 is equal to 27 seconds. So it would take 27 seconds for this capacitor to have its charge, voltage, and current to drop to 37% of its original value. Now, once you know this number, you can actually do a lot of things with it in terms of like capacitor discharge. There's 3 main formulas that you need to understand and know how to use when it comes down to capacitor discharge. The first one, and that's the most important one, is Q equals to Q0 times e to the power of negative t over RC. This formula is found using some equations in calculus. You don't need to know the proof of this formula. And then from this formula, if you take the natural logarithm from each side, you can actually get to the formula of voltage left on the capacitor, which is V equals to V0 times e to the power of negative t over RC. And finally, I equals to I0 times e to the power of negative t over RC. All these 3 formulas give you the charge, voltage, and basically any given other value when it comes down to capacitor discharge. You also need to kind of sometimes use the Ohm's law, and that one is R equals to V over I. This is used to find initial current sometimes. So I will be just voltage divided by the resistance. And Q0 is usually just found simply by multiplying the capacitance of the circuit by the voltage of the circuit. Now, T here stands for time. So usually what they do is you can graph time. You have a graph of like the charge on the capacitor against time, and then if it's discharging, the graph is going to be a graph which basically shows exponential decay, because discharge is when the capacitor loses its charge. However, if it's charging the capacitor, then the graph would be the opposite, because the charge on the capacitor is going to increase. So if it's discharged, then if this the Q is going to be on this vertical axis and the time here is going to be on the horizontal, then you would have a graph that roughly starts at the top and the charge goes down as the amount of time passes, because charge is going to decrease as the time goes on. Now, one thing we need to understand here is usually we're given problems which give us certain informations. For example, here, I've gotten this from the Pearson Excel book. It says that we have a capacitor that's fully charged, and then it's allowed to discharge. What is going to be the charge remaining on the capacitor after 20 seconds? So if you want to find the charge remaining after 20 seconds, you have to actually use the formula Q equals to Q0 times e to the power of negative t over RC. Now, here, we can actually go ahead and plug in the values we found. We found that R times C is the tau. So we can say that instead of this RC, we can just say it's tau, and tau has a value of 27. Also, we don't happen to know Q0, so we can find Q0 by using the formula C times V. So we can say that 0.03 times 12 will give us the initial charge. And the initial charge would then have to be about 0.36 coulombs. So we can find the charge left after 20 seconds simply by multiplying 0.36 by e to the power of negative 20 over 27. So the charge left on the capacitor is going to be, make sure you put e correctly in your calculator, raised to the power of negative 20 over 27. So the amount of charge left on the capacitor after 20 seconds pass is 0.17 coulombs. Now, the question could also ask you for the amount of voltage or the amount of current remaining on the charge. So I'm going to add these by myself. So B, what is the voltage and current remaining of course on the capacitor after 20 seconds. So if you want to find out the voltage remaining, we know that V initial is actually 12 volts. And if you want to find V is just going to be 12 from the formula V equals to V0 times e to the power of negative t over tau. We can say that it's going to be 12 times e to the power of negative 20 over 27. So that would give us a value of roughly 5.72 volts. So that's going to be the voltage after 20 seconds. And finally, if you want to find out the amount of current left after 20 seconds, you can simply go ahead and use I equals to I0 times e to the power of negative t over tau. Notice that I'm using tau instead of R times C because they give the same value. Now, I0, we don't have the value of the initial current, but we can use the Ohm's law that I mentioned at the beginning to find it. We know that I is going to be the initial voltage divided by resistance. The initial voltage is 12, and we can divide that by 900 ohms to find the amount of initial current. 12 divided by 900 is 0.013 amps. So the amount of the current left is going to be 0.013 amps multiplied by e to the power of negative 20 over 27. And so that would give us a value of, let me calculate that. Actually, it's going to be a really small value. It's going to be 6.19 times 10 to the power of negative 3. So that's going to be the value of the amount of current left after some time passes. So 6.19 times 10 to the power of negative 13. Thank you for watching, and I hope that you can learn this topic well and do the best of your abilities in all of your exams. Take care.